Proportional and non-proportional situations. How can you tell the difference between a proportional and a non-proportional situation? We're going to take a look at it several different ways, and hopefully by the time we're done you should be able to tell the difference. So let's first take a look at a graph. One of these is proportional, one of these is not proportional. If we look at the graph, we'll notice that this graph passes through the point 0, 0. This one here passes through the point 0, 6. We know that in order for it to be proportional, it must go through the origin. It is not proportional when it passes through another point other than the origin. So that's our first part of our definition of proportional versus not proportional. Our second part of our definition deals with equations. Here we have two equations, y equals 2x and y equals 3x plus 15. Now one of these is proportional and the other is not. The difference, as we can see it, is over here on the right, it has a y-intercept of 15. On the left, there's nothing sitting out there, which means it's 0, and this has a y-intercept of 0. When we have a y-intercept of 0, we know that that's proportional, that there's nothing else going to affect the change, that the change then becomes constant. Here, whenever we get a number other than 0, we know that it is non-proportional. So let's review right now. So far we know if it's proportional, the line of the graph will go through the origin and the y-intercept is 0. If it's not proportional, the line of the graph will pass through any point but the origin and the y-intercept does not equal 0. So let's add one more thought to this, and I'm going to use these words: constant of proportionality. Okay, and we're going to use y divided by x. So this constant of proportionality is going to help explain why something may be proportional or not. So let's take this apart. First, the word constant. Constant means the same thing all the time. Proportionality, if you remember, if we had a proportion, we basically have two fractions that are equal to each other. So here I have two tables. One is proportional and one is not proportional, and the best way is to evaluate the constant of proportionality. So we're going to take a look at the y and the x values as an ordered pair. This first one, if I take 4 and divide it by 1, that equals 4. If I take the second pair and do 8 divided by 2, that also equals 4. And the same is true for 3/12. If I take 12 and divide it by 3, it equals 4. Since I get the same number all the time, it is constant, we can say the constant of proportionality exists for this table of values, so therefore it's proportional. Now there's a reason why this one is not proportional. Obviously one is one and one is the other, but let me show you so that you can see, in fact, the numbers, why it's not proportional. Again, we're going to use this x and y values of the ordered pairs. Here I'm going to have 5 and divide by 2, I get 2.5. Here I have the pair 3 and 7, so I'm going to take the y, which is 7, and divide it by 3, and I get 2 1/3. We can already see that it's not the same. But let's just do one more to make sure we all understand. 9 divided by 4 is 2 1/4. So we can see the constant is not the same. The constant of proportionality does not exist. Since it does not exist, it is not proportional. So